Remember logging into your bank account in 2003? Type in your password and you're in. Now try that in 2025. It doesn't work. Even if you type in the right passcode, you'll still need another code to actually get in. It's kind of annoying, but the truth is, this two-factor authentication has made hacking exponentially more complicated than it was before, all because of a string of 6 or so numbers. In the most extreme cases, you'll need entirely different apps, like the Google Authenticator app, which gives you a random string to help you log in. And with millions of people trying to log in every day, and likely billions of these unique strings being used, this seems like it would take a lot of time to process. But wait, time. Let's think about time for a second. It only moves forward, and every moment is unique. It never repeats. This is the first step to understanding how authenticator apps and 2FA codes work. Every 30 seconds, it takes the current time, combines it with a secret key unique to your account, and runs it through a special mathematical formula to generate that 6-digit code. Take a random time, let's say 3:45 p.m. Right at that moment, your code might be 847593. 30 seconds later, that code is worthless, replaced by a completely different one. Even if a hacker intercepts your code, it's like giving them a key that dissolves in 30 seconds. But here's where it gets really clever. Your phone doesn't even need to connect to Google to generate these codes. Both your phone and Google's servers are running the exact same mathematical formula using the exact same secret key. They just need to agree on what time it is. It's like two perfectly synchronized watches, ticking away in harmony, generating matching codes every 30 seconds. This is why you can generate codes even in airplane mode, underground, or in the middle of nowhere. But this by itself isn't what drives the system, because what if someone's clock is faulty? The entire time-based check falls apart. So there's another portion to make sure all this works, something called HMAC SHA-1. In Google's case, a cryptographic algorithm that turns two pieces of information into an unpredictable but repeatable code. Think of it like a highly sophisticated blender. Put in the same ingredients, you'll get the same smoothie every time. But change even a tiny ingredient and you'll get something completely different. When you first set up Google Authenticator by scanning that QR code, you're actually receiving a secret key, a string of random data that both your phone and Google will store forever. This key is like a special recipe that only you and Google know. The current time, divided into 30-second chunks, is the other ingredient. Here's what happens every time you need a code. Your phone takes the current Unix timestamp, let's say 17056411600 for 2 p.m., divides it by 30 to get the current time chunk, and combines it with your secret key. This mixture goes into the HMAC SHA-1 algorithm, producing a 20-byte hash. But that's too long for humans to type, so the app performs some clever math. It looks at specific bytes of this hash, converts them to a number, and takes just 6 digits from the result. Then it goes and stores them in a vault. Wait, no they don't. In fact, Google doesn't store any code for anyone, much less than it very accurately guesses what your code should be. In fact, to prevent time discrepancies, the system checks the 30 seconds before, during, and after you generated your code, just in case. This seemingly simple system of 6-number codes is quite literally unbreakable. Without the secret key, it's impossible to predict the codes. And even if a hacker does manage to get a code, they have just seconds to use it before a new code is spat out. And this even works if your phone is completely dead, because Google does something a little more clever than second-by-second checks. They actually look at a small window of time, typically one interval before and one after. So if your phone's clock is off by a few seconds, or there's a slight delay in typing or submitting the code, it still works. But what about when things really go wrong? This is where backup codes come in. When you first set up Google Authenticator, you're often given a set of emergency backup codes, usually 8 or 10 of them. These are single-use lifelines, in case everything fails. Each can only be used once, and once used, it's gone forever. In more recent times, these keys are being put onto the cloud, which makes them more convenient for us to reach, but technically less secure, as they're not completely offline. Perhaps most fascinating, though, is how the system handles time drift itself. No two clocks are ever perfectly in sync, and if your phone's clock starts to wander, Google's servers can detect this by looking at patterns in the codes you submit. They'll actually calculate how far off your device is, and adjust their verification window accordingly and automatically so the system doesn't fail. But the real genius of Google Authenticator isn't just in its cryptography when it works, it's how it manages when the system does indeed fail. Because every system, will eventually fail. Speaking of, thanks so much for all the support on the channel lately. It really means a lot, and I want to give something back to you guys. So do you need a job? That sounded a bit weird. But whether you're a UX designer, app developer, freelancer, or just a curious viewer, I want to get to know you guys, share some UX and UI tips, and maybe even get a gig. So I made a Discord channel for us and want to make this the place to be for front-end professionals. And I'm having talks with people to get some employers in there so you can connect with them too and find some jobs in the future. I'm really excited to get this thing started, so I hope you'll join me. To handle billions of daily verifications, Google employs a network of specialized hardware security modules, or HSMs, spread across data centers worldwide. These aren't just regular servers. They're tamper-resistant physical devices with their own processors, memory, and encrypted storage. If anyone tries to physically open or tamper with an HSM, it automatically wipes its contents. These modules are specifically designed for one task: ultra-fast cryptographic calculations. Each HSM can process thousands of verifications per second while maintaining perfect synchronization through atomic clocks. They're also designed with redundancy. If one HSM fails, others seamlessly take over, ensuring your login attempts never fail due to server issues. The concept of forward security is one of Google Authenticator's most elegant features. Every time a code is used, it essentially vanishes into digital nothingness. There's no server log of previously used codes, no record of when they were generated, and no mathematical way to reconstruct them, even with the secret key. This creates what security experts call perfect forward secrecy. Even if a hacker somehow gained complete access to both your phone and Google's servers right now, they couldn't piece together your login history or figure out when and where you previously accessed your accounts. It's like having a key that unlocks doors but simultaneously erases any evidence that the door was ever opened. Each authentication is an isolated moment in time that exists only while it's happening. But perhaps most interesting is how Google Authenticator handles attempts to clone it. The app includes subtle security measures that make it extremely difficult to run in emulators or on rooted devices. It can detect when someone tries to screenshot your QR codes or secret keys, and even newer versions use your phone's secure enclave, the same hardware that protects your fingerprint data, to store the keys. But there's always ways to be even more secure, and Google is obviously investigating those already. One example are passwordless systems where your phone becomes your only authentication method, like Face ID and other biometric indicators. These biometrics are being integrated directly into the authentication flow. Imagine your fingerprint replacing that 6-digit code. AI systems are learning to detect when someone else might be trying to log in as you, based on behavior patterns and device fingerprinting. And when quantum computers inevitably make their way out into the world, something more needs to be done. When that happens, we'll need entirely new ways to prove who we are online, to prove that we exist. But proving that a person exists is entirely different from proving that a place exists, and Google Street View does that with a completely different set of technology, mapping out the entire planet while they were at it. How exactly did they do it? Well, click here to find out.